Hello everyone, today we will be solving question number 8 from GATE 2020 question paper. The question is the correct statement regarding the substitution of coordinated ligands in NiCO whole 4 and CONO CO whole 3 complex is. The options given are option number A, nickel tetracarbonyl and cobalt NoCO3 follows associative and dissociative pathways respectively. Option number B, nickel tetracarbonyl and the cobalt complex follows dissociative and associative pathways respectively. Option number C, both nickel tetracarbonyl and the cobalt complex follow associative pathway. And option number D, both nickel as well as the cobalt complex follows dissociative pathway. So in this question, they have asked us that what type of substitution reaction is taking place in these two complexes. This is what type of ligand substitution reaction. So, first of all, what is a ligand substitution reaction? In this case, both the complexes which are given, NiCO whole 4 and CONO CO whole 3, they are having a coordination number of 4. So, ligand substitution reaction for these type of reactions is of this form. There will be a metal complex of Ml3X type and one incoming ligand will attack and we will get a resulting ligand substituted product in which this metal is now coordinated to this incoming ligand and this X, this ligand, it leaves. So ligand substitution reaction can take place in associative or dissociative way. So first coming on to the associative mechanism. In associative mechanism, the reaction intermediate has higher coordination number than the reactants or products. So in associative mechanism, Ml3X reacts with Y to first give the associated complex Ml3XY and then the ligand X releases and we finally get the ligand substituted product. So here Ml3X is having a coordination number of 4, Ml3XY is having a coordination number of 5 and the product is having a coordination number of 4 again. This associative mechanism is observed for 16 electron complexes. Moving on to the next way is dissociative mechanism. This is the other pathway by which ligand substitution reactions take place. So in this case, the reaction intermediate is Ml3, which is having a lower coordination number than both the reactant and the product. So here the reactant is again having a coordination number of 4, whereas Ml3 is having a coordination number of 3 and Ml3Y is having a coordination number of 4 again. So in this case, what happens is from this Ml3X metal complex, first the X dissociates and gives Ml3 plus X and after that this Y, this incoming ligand will attack this Ml3 complex and give the ligand substituted product Ml3Y. Dissociative mechanism is observed for 18 electron complexes. So in the question, the two complexes which are given are nickel tetracarbonyl and cobalt CO whole 3 NO complex. So first of all, we will find out whether these complexes are 18 electron complexes or 16 electron complex. So first we will check for nickel tetracarbonyl complex. Nickel is having an electronic configuration of 3d8 and 4s2. So when this complex is there, nickel is a, here the oxidation stage of nickel, if we consider it as X, then X plus carbonyl is a neutral ligand, it don't carry any charge. So 4 into 0 is, again this complex is neutral, so the overall charge of this complex is 0. Therefore, X is equal to 0. So the oxidation state of nickel here is 0. And hence it is a D10 system in this complex. So nickel will give 10 electrons and carbonyl is a 2 electron donor. 4 carbonyl ligands are present. So 4 into 2, that is 10 plus 8 or 18 electron system. So NiCO whole 4 is an 18 electron system. Now we will check for the cobalt complex. So here also, first we have to see that we know that cobalt is having an electronic configuration of 3d7 4s2. So if we count the neutral method of counting to the valence electrons, then since it is a D9 system, we will get 9 electrons from cobalt. Carbonyls donate 2 electrons each, so 3 into 2, which makes 9 plus 6. And now we have to know how many electrons NO is donating. So NO means nitrosyl ligand, and this nitrosyl ligand can coordinate in two fashions. One is bent mode, the other one is linear mode. If NO is coordinated in a bent fashion, then it is a 1 electron donor and it is present as NO minus. Whereas if nitrosyl is coordinated in a linear fashion, then it is a 3 electron donor and NO is present as NO plus. So here if we look into the question, they have given that the CONO, that is cobalt nitrogen oxygen bond, is nearly linear in this complex. This means that NO is coordinated in a linear fashion here. So it is a 3 electron donor. Then 3 electrons will come from this, which will make 9 plus 6 plus 3, which is again equal to 18 electrons. So both the nickel and the cobalt complex are 18 electron complexes. So from this then we will think that, as we discussed, that for 18 electron complexes, dissociative mechanism takes place for ligand substitution. But what we have to see is, like here as we said that in this cobalt complex, nitrosyl ligand is present, which can coordinate in both bent and linear fashion. So now this is coordinated. Let's say there are 3 carbonyl ligands and it is coordinated in a linear fashion. That's why it is an 18 electron complex. But the NO can also coordinate in bent fashion like this, and in this case what will happen? 2, 2, 9, 2 and 1, that is 9 plus 6 plus 1, it will become a 16 electron complex. So if any such kind of ligand is present which can change its mode of coordination, and by that it can change the number of electrons it is donating, for those cases it will change the mode of coordination with the metal center and it will become a lower electron complex, and hence it will now prefer. We have seen that for 16 electron complexes, associative mechanism is observed. So it will now prefer to go for ligand substitution reaction via associative mechanism. Okay. So in nickel case, what is happening is we have 4 carbonyl ligands, CO, 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 and CO. Dissociative mechanism is taking place here because CO can coordinate only in one way and it will donate 2 electrons. So it is an 18 electron complex only. That's why dissociative mechanism will take place. So first one CO will leave, making an empty space, and now one incoming ligand, let's say Y, it will attack this complex and nickel, CO, 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 and Y. This ligand substituted product will form. Whereas for the cobalt complex, the mechanism will be like first there are 3 carbonyls and nitrosyl coordinated in a linear fashion. It is an 18 electron complex now. Then what will happen is the nitrosyl will coordinate in a bent fashion, making it a 16 electron complex. So now what will happen is the incoming ligand will attack this metal complex and then it will form a complex with coordination number of 5. So cobalt with 3 carbonyl, sorry, not 3 carbonyl, 1 NO. It will be coordinated with 3 carbonyl, 1 nitrosyl ligand, and this incoming ligand Y, and then one of the carbonyls will get eliminated and we will get the ligand substituted product. Okay. So now coming back to the question that that is, what is the correct statement regarding the substitution of coordinated ligands in nickel tetracarbonyl and cobalt NO CO 3 complex? For nickel tetracarbonyl complex, we found out that the ligand substitution will go via dissociative mechanism, and for the cobalt complex, just because of the presence of this nitrosyl ligand, which can change its donation from 3 electron to 1 electron, it is becoming a 16 electron complex from 18 electron complex and therefore preferring associative mechanism for ligand substitution. So the correct option will be dissociative mechanism for NiCO4 and associative mechanism for the cobalt one. That is option number B. Nickel tetracarbonyl and cobalt NoCO3 follow dissociative and associative pathways respectively. To know more about this topic, please watch the Coordination Chemistry lecture series by Professor Debashish Rai from Department of Chemistry, IIT Kharagpur. This is the link given for his lecture series. Please go ahead and watch the video. Thank you.